Hi, my name is David Villar, and welcome to this video where we are going to see a case in which a drug intended to have some therapeutic action turns into a toxic one. I'll present the case, and in the end we'll ask some comprehension questions, and the idea is that you will do literature research and come up with the answers to some of the questions. When we refer to pharmacokinetics turning into toxicokinetics, we basically want the toxicants or toxins, depending on what their nature is, and not to be absorbed into the body. Now, if they have already been absorbed, the next step would be distribution. So if there are ways to prevent their distribution, we would ideally want to implement them. And if they have distributed, what we would like to do is to speed up the elimination out of the body, which is opposite of what we pursue in pharmacokinetics. In pharmacokinetics, we want the drug to remain in the body, so the duration of action also lasts longer. And in pharmacokinetics, we want the drug to be absorbed in the body, so that and be distributed. And as you can see, this is also opposite from toxicokinetics. I chose to talk about ionophores as an example of drugs producing intoxications, because you will find many examples in the literature of unfortunate incidents of this group of drugs that results in the mortality of many animals. These are actually a group of antibiotics that are exclusively used in food animals to improve weight gains and feed efficiency. And of the different ones that we see here, monensin, lasalocid, salinomycin, only narasin remains as the one approved for use in swine in the US. It has no withdrawal time, and it doesn't require a veterinary feed directive, which are two attractive points for the producer. Now, the trade name of narasin is Skysis 100, which is sold by Elanco, and the label has a specific cautionary statement that swine-fed Skysis should not be given thiamulin or other pleuromutulins. And the other thing that we should point out is that the safety margin is only 1.5 above the therapeutic dose. In other words, if you give twice the therapeutic dose, you already are into the toxic range. So you have to be very careful when you mix or prepare the ration, so you don't really exceed the proper dose. Now, the case that I'm going to present took place in Kansas in two feedlot cattle that were feeding distillers' grains. And as you can see here, they lost a lot of cattle after introducing a new batch of distillers' grains. 52 head in the first 6 days, 200 in 8 days, 450 animals by day 12, and in total they lost 562 animals out of the 988 animals they had in the feedlot. Now the second feedlot, they didn't lose that many, only 50 out of 100 out of 500. So how did they actually approach the investigation in this case? Well, the first thing you do in a case like this one is to necropsy the dead animals and basically come up with a list of differentials for the type of lesions that you find on those organs. And actually what they found is that the main organs affected were the heart and the skeletal muscle. And on these two images we see the cross section of the heart with pale striations in the interventricular septum. There were multifocal hemotic hemorrhages throughout the heart. And in the skeletal muscle there were pale areas of discoloration next to the normal looking color of the muscle. And when they look at these gross lesions on the microscope, they could actually confirm that the cardiac fibers were necrotic and fragmented with loss of their normal striations. And so were the skeletal muscle fibers. And what we can see in these images, basically the heart on the right and the skeletal muscle on the lower images, and I'll let you look at these images more if you like at your leisure time. Now the other thing that was happening is that because the organ that was being affected was the heart, which cannot regenerate, unlike the skeletal muscle, many of those animals could never actually recover. They were left with a chronic heart failure condition from that initial incident. And in this image they put down a steer that was actually lingering and doing poorly after 6 weeks from that initial toxicosis. And what we see here are basically areas of myocardial fibrosis and degeneration on the epicardial surface of that ventricular wall. And when they look at that area under the microscope here on the left image, we can see those necrotic fibers that have been replaced by fibrous connective tissue. And there were also some degenerate myocardiocytes that have basically completely lost all their cross striations. So basically, as I said, there are many cases in the literature of ionophores that have caused intoxications, and I'll let you do some homework on that feedlot case and show you another case here that involves swine. And this took place actually in the Oklahoma Panhandle in 2014. There is a very nice YouTube presentation of the case, and I invite you to watch this video by Dr. Rebecca Robbins if you want to watch the clinical signs of the animals exposed to an excess of narasin. So this case is also published in the Journal of Swine Health and Production, in case you want to read a little bit more and find some additional information on this case. But basically, this was a swine farm of 3,000 finishing pigs. They lost a lot of pigs, 86 dead, and they also had to sacrifice 415 pigs on humane grounds. They basically found a broken load cell in the feed meal that was allowing excretion to be at very high concentrations in many of those batches, concentrations well above the 30 parts per million, which is the normal label concentration. And basically, the way they diagnosed the case was by initially suspecting that something was affecting the skeletal muscle systems based on the clinical signs, and by finding the lesions of necrosis and degeneration on those skeletal muscles. And basically, of the different things that could be causing those signs and lesions, the number one in the differential list was the ionophore. And when they measured the high concentrations in the feed, they could actually confirm that that was what was actually happening. Basically, the schisis was bypassing the liver at those high concentrations and getting into the systemic circulation because of the high concentrations. And the conclusion of the case was that when they removed the feed with the high excess of schisis, those pigs that were sick started making a quick recovery because the skeletal muscle, which is actually the target organ, is capable of regenerating within very quickly. And within 14 days, all the clinical signs disappeared, and all the animals could be sent to market within 9 weeks of the incident. And that was actually quite lucky for the producer. Now, for example, if I show you some of the images, we can see some cross sections of the organs with skeletal muscle and some smooth muscle fibers. The interesting thing here is that even though we see inflammation in the diaphragm and the esophagus, there is no necrosis of the muscle fibers on the two images on the top. And if we look at the ham and the loin on the lower images, we can see that the pigs, this one pig had no necrotic fibers, and instead there are many small little ones that are actually replacing or regenerating the ones that have been lost. And this is actually a good thing, as I said, because the skeletal muscle can regenerate, unlike the heart, which is an organ not capable of doing so, as we saw for the case in the cattle. So as a final slide, here are some critical thinking questions for the investigator. After completing a literature review like you did, describe some key steps you'd like to investigate in the mortality for the cattle case. Using your understanding of pharmacokinetics, the precedent case and the precedent case in pigs suggests some molecular mechanisms and organ perturbations that might lead to toxicity in the cattle cases that would be more severe in the literature case for the pigs. And finally, what was a major difference in the long-term impact of the toxicosis for the producer between the swine and the cattle case. So this is my final slide. I will let you go away and see if you can come up with some of the answers to these questions. I hope these cases spark your interest in learning more about this fascinating profession of ours, which has always something new to teach us around the corner. So I look forward to interacting with you guys in future presentations. So until next time, bye bye for now.